Okay, here's the recording in progress. All right, first announcement. We should not have any more issues about that 40-minute limit. I decided to go ahead and pay out of my own pocket the extra $15 a month, rather than trying to go through all the red tape of getting it, the school to do it and filling out this form and doing this and that and the other thing. I said, forget it, I'll just pay it. So I paid the extra $15 a month and I'll just write it off on my taxes, I suppose. So I don't think we'll have any more issues about the 40-minute thing. Well, the previous hour, it seemed to work. My previous class was more than 40 minutes, and I didn't see that message that said you'll be bumped out after 40 minutes. So hopefully that takes care of that the rest of the semester. Okay, so we're doing graphs of sine and cosine and so forth. So we'll continue on. Quiz on Friday, quiz Friday after that, but the next exam is on November the 5th, it looks like. Okay. So we are somewhere over here. All right, but before doing that one, I do have a request to go back and do 4.4, number 55. So let me show you how that one works. Okay. So 4.455, solve for sine t plus cosine t equals 1 on the interval from 0 to 2 pi. And side note, remember that sine squared of t plus cosine squared t is equal to 1. Okay, so the way you can work this out is to move one of them over. I decided to move the cosine over. So sine of t equals 1 minus cosine t, and then you square both sides. So that gives me sine squared of t is equal to 1 minus cosine t squared is 1 minus 2 cosine t plus cosine squared of t. Okay. And then I change sine squared of t to 1 minus cosine squared of t. That way, the entire equation has only cosine involved. So I want to get it down to just a single trig function. So sine squared is equal to 1 minus cosine squared. That's based on this identity, sine squared t plus cosine squared t equals 1. Okay, subtract 1 on both sides, they're gone. And then what happened after that? Let's see, I added cosine squared t on both sides. So that means I now have 2 cosine squared t minus 2 cosine t equals 0. Factor out the 2 cosine t minus 1. So that means cosine of t is 0 or cosine of t is equal to 1. So where's the cosine of t is 0? X coordinate is 0. Well, that's here and here. Where's the cosine of t equal to 1? Well, that's right here. Okay, so I have pi over 2, 3 pi over 2, 0, and 2 pi. However, each of those has to be checked. Okay. I'm not sure if your algebra teacher taught you this, but anytime you square both sides, you might accidentally introduce a solution which is not really a solution, it's a fake solution. So you have to go back and double check each of these to see if they work. Okay, so go back and check them all. If I plug in 0 to the original, I have sine of 0 plus cosine of 0, that's 0 plus 1, which is 1. That's true. And that means automatically I know 2 pi is going to work, because whatever I plug in for 0, I get the same thing if I plug in 2 pi. Okay, try pi over 2. Sine of pi over 2 plus cosine pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0, so I also get 1. However, I do have to throw out 3 pi over 2. That's not going to work. Okay, so if I plug back into the original, sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. Negative 1 plus 0 is negative 1. That is not true. So I throw out 3 pi over 2. So the only solutions really are 0, pi over 2, and 2 pi. Okay. So notice if you didn't bother to check your answer, you would have put down 3 pi over 2, which is not a solution after all. Okay. Well, this gets a little bit deeper than maybe we want to do, but I think it's worth mentioning. If I plug in 3 pi over 2, my equation says negative 1 equals 1. And we know that's not true. But what happens at the step where I square both sides, If you have negative 1 equals 1, if you square both sides, you get 1 equals 1, then all of a sudden it's true, right? So that's what I mean by squaring both sides, you might accidentally introduce a solution, which is not a solution after all. So that's why you have to check your answer. Okay. Then this little acronym I gave before, I'll give it to you again. You can just put this in your cheat sheet. If we were meeting face-to-face, I'd make you memorize this. But this little table I gave a while back, okay, the memory trick was all students take calculus, which is not really a true statement, of course, but it's just to help you memorize this thing. Okay. So between the sine, cosine, and tangent, what's this A, S, T, C all about? If you had to memorize it, one way to memorize it is all students take calculus. Meaning for sine, cosine, and tangent, A stands for all of them are positive. Second quadrant, S stands for sine is positive, which means the other two are negative. Quadrant 3, T stands for tangent, therefore the other two are negative. And fourth quadrant, C is cosine is positive, then the other two, sine and tangent, are negative. So here all three are positive. Only the sine is positive, the other two are negative. Only the tangent is positive, the other two are negative. And only the cosine is positive, the other two are negative. Okay, so the memory trick was supposed to be all students take calculus. But anyway, that takes care of that. All right, so now let's work on some of these graphs. And before doing that, do a little bit more work on amplitude and period. Okay, so these are not necessarily problems in the book, but it's just some warm-up exercises. So our basic sine function has a period of 2 pi. Cut that in half, pi. Cut that in half, pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay. Sine goes 0, maximum 0, minimum 0. Okay. And I say 0, officially it's really the midline. I'll talk more about that when we get to it. Okay. And when you put a 2 there, that gives you a vertical stretch. We talked about that before. So whereas the original sine function in red, the highest value, the maximum value is 1, but because I have a 2 there, it's not going to go up to 2. And likewise, here when y is -1, -1 times 2 is -2, is going to jump down to -2. But notice they always come back at 0, because 0 times 2 is 0. So that stays the same, that stays the same, that stays the same. But here the maximum is 1, here the maximum becomes 2. And here the minimum is -2. Okay. Imagine the coefficient in front here was 1,000,000. Well, this thing would shoot way up here to 1,000,000, but still comes back down to 0. Then it shoots way down to -1,000,000, and then it comes back to 0. And it keeps doing that all the way through. Okay, the amplitude is 2. There's also a formula for amplitude. So you might say, why don't I just look at the coefficient here? That's true, but you may not always be able to do that. So a very formal definition of amplitude, you can put this on your cheat sheet, is maximum minus minimum divided by 2. Maximum minus minimum divided by 2. So how would that work in this case? So let's say the regular sine function has an amplitude of 1. You would go 1 minus a -1. 1 minus a -1 is 2. Divided by 2 is 1. Similarly, over here, the amplitude is 2. Yeah, it's just a coefficient here, but the maximum is 2. The minimum is -2. So if you go 2 minus a -2, that's 4. 4 divided by 2 is 2. Yes, in these cases, it might be considered trivial, but later on, it won't be trivial because they don't give you a coefficient, or they'll say the maximum is 7 and the minimum is -3. Then how do you figure out the amplitude? Then you would have to use this formula. Okay, so put this on your cheat sheet. Amplitude is, well, don't put the 2 here. In general, amplitude is max minus min divided by 2. Okay, now what about -2 sine x? Well, we know all that does is reflect the original across the x-axis, which means this is the original sine of x. Instead of starting up, it starts down. Goes down, and then over here, where it normally would go down, it ends up going up. Okay. So the amplitude is still going to be 2. By formula, it's the absolute value of A. So getting back to what we were here, right? The amplitude is the absolute value of A. So the absolute value of -2 is 2. And notice it still fits the formula of maximum minus minimum divided by 2, right? Even though it starts down and goes up, the maximum is still 2. The minimum is -2. 2 minus a -2 is 4. Divided by 2 is 2. So it starts down. Okay, so what's the effect of having a negative? Then that reverses what happens, whoops, over here. Okay, so instead of going 0 maximum, a sine function would go 0 minimum, 0 maximum 0. It just reverses what normally happens. And likewise for the cosine. Okay, so we said for cosine, it goes maximum, 0, minimum, 0, maximum. Again, 0 really should be midline. I'll get to that later. But if you have a negative in front, then it switches. It will go minimum, 0, maximum, 0, minimum. Okay, so an example is -3 cosine x. Okay, so regular cosine goes maximum 1, 0, minimum -1, 0, maximum. That's one period. And this is every quarter. So this is 1/4 of the way, halfway, 3/4 of the way, full way. So starting at 0, maximum, 1/4 of the way, 0, halfway, minimum, 3/4 of the way back to 0, and then the end of a period, maximum. Because of the -3, it goes down to -3, goes up to +3, and because of the negative, it starts at the minimum. So notice here it's max, but this is min. Back to 0. And where you used to have a minimum, it's now a maximum. Back to 0. And instead of maximum, minimum again. So here's -3 cosine x. A couple more examples by way of introduction. Okay, let me change the period. So the formula for the period is 2 pi over, strictly speaking, absolute value of b, but we're almost never going to have to worry about that being negative. So we'll just say 2 pi over b. That's what the book did. Okay, and in general, I'm not going to worry about putting a negative there. Okay, so y equals sine 2x. Amplitude is 1, the coefficient is 1. So the maximum and minimum are still going to be 1 and -1, but the period has changed. 2 pi divided by 2 is pi. So one complete cycle, one complete up and down period is finished after pi. Okay. So whereas the original sine function in red goes 0, maximum, 0, minimum, 0, that whole period gets scrunched in. Imagine this is a spring and it just compressed that spring up to here. So that whole up and down cycle has to finish by the time it reaches pi. So I break that into 4, and then it goes 0, maximum, 0, minimum, 0. So one complete period is here. You can almost think of it as it's going twice as fast. And then I just do that same thing again, maximum, 0, minimum, 0. So notice in green, I've already finished 2 periods. In the same amount of time, it takes the original sine function to finish 1 period. Think of a spring. I'm just compressing the spring. I'm just squinching it in like that. Okay. So it's like a horizontal compression. Now, what if I fraction like cosine half x? That's going the other way. That's a horizontal elongation. Imagine taking this spring. If I would take the spring, instead of scrunching it in, I'm pushing it out. Okay, I'm making it go out. So suppose I have cosine half x. So by formula, well, the amplitude is still 1. So maximum, minimum is still 1. The period is 2 pi divided by a half. Dividing by a half means multiplying by 2. So 4 pi. So whereas the regular cosine function in red finishes a whole period after 2 pi. Imagine taking this red graph and stringing it out this way. So it has to go all the way out to 4 pi until I finish a period. So I go all the way out to 4 pi, and chopping that into 4 pieces is not that hard. You know, pi, 2 pi, 3 pi, 4 pi. And then I do the pattern for cosine, max, 0, min, 0, max. So where was I? Okay, maximum, 1, 0, quarter of the way, minimum, halfway, 0, 3/4 of the way, maximum. Excuse me. Right, so the regular cosine function finishes one period after 2 pi, which means by the time it reaches 4 pi, it finishes another period. So notice in red, there's 1 period, 2 periods, but this one is lagging behind, so to speak. It takes an entire 4 pi to finish one cycle of going maximum, 0, minimum, 0, maximum. Okay. So now with that background, we're going to tackle some of these guys here. Okay, so I don't remember if I showed you this form of the problems. Well, I'll show it to you again anyway. So what do we have? 1 to 25 odd 35 on page 229. Okay, so once again, for the benefit of those of you who don't have the book and aren't planning to get it, on that. So here. And let's see, 35 we had to go to. So here's 35. Yeah, okay. So here's how we analyze it. Okay, 1c, y equals 1/4 cosine 4x. Amplitude, 1/4. So we're only going to go up to 1/4 and go down to -1/4. So usually we would go from -1 to 1. This one, because of the 1/4, it squinches the whole graph only between -1/4 and 1/4. The period, by formula, it's 2 pi divided by this b, 2 pi divided by 4 is pi over 2. So I finished one complete period by pi over 2. Cut that in half. Half of pi over 2 is pi over 4. Cut that in half, pi over 8. So pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. Maximum is 1/4, minimum is -1/4, and I don't have a negative here. If I have a negative, like on this one, I'll show you what to do. Then I just follow the pattern of a typical cosine. So cosine goes max, 0, min, 0, max. So we go maximum. So I thought the cosine maximum was 1. Yes, but because it's a 1/4 there, it's a vertical compression, right? So it's only going to go as high as 1/4, and it's only going to go as low as -1/4. So maximum, 0, minimum, 0, maximum. That's one period. And then it's just a copy and paste. So imagine copy and then paste, paste, and over here too, paste, paste, infinitely far, both to the left and to the right. Okay. 2C, I realize it's an even one, but I want to emphasize something there. So 2C, -2 sine of 3x. Okay, the negative means for the sine function, the max and the min swap. So it's going to go 0, min, 0, max, 0. That's the effect of the negative. The max and the min just switch because the negative, of course, as we saw earlier, reflects across the x-axis. All right, amplitude is 2. Amplitude is always a positive number. So if they give you a -2, just say the amplitude is 2. Following this formula, amplitude is the absolute value of A. And the period is 2 pi divided by B, 2 pi over 3. So I complete one full period after 2 pi over 3. Okay. You always want to take your region and cut it into quarters. So I cut in half, half of 2 pi over 3, 1 pi over 3. Half of that, pi over 6. If you want to see the calculation, it's 1/2 of pi over 3, which is pi over 6. Yeah, the 3/4 mark tends to be the most problematic for students, but here's how you can count. Okay, pi over 6, 2 pi over 6. Isn't 2 pi over 6 the same as pi over 3, right? 3 pi over 6, and 3 pi over 6 reduces to pi over 2. And even 4 pi over 6. 4 pi over 6 reduces to 2 pi over 3. All right. So a regular sine function goes 0, max 0, min 0, but because there's a negative in front, this with the quarter mark is a minimum, and the 3/4 mark is a maximum. So 0, min, which is -2, 0, max 0. And there we go. Okay. So that's the way it goes. Okay, now 229.11. I'm going to do it a different way, and I want you to do it the way I'm showing it to you also. Okay. What the text has is correct, but what I'm doing is more consistent with what we've been doing the entire time. So I'm going to basically factor out the 2. I'll show you how to do that. 1 plus cosine 2x plus pi. Factor out the 2. 2 parentheses x plus. Okay, so how do I do this? Well, here if you multiply by 2, to make it balance, you would divide by 2. So x plus pi over 2 plus 1. Okay, so one more time. If I'm taking a 2 out, if there's a 3 here, I would take out a 3 and then make that pi over 3. Okay. And what should confirm everything is, go ahead and multiply this back out. What happens when you distribute? 2x plus 2 pi divided by 2, which is pi. So once again, what the text has is correct, but this is more consistent with what we've been doing the whole semester. If you look at this, before we said, oh yeah, that's pi over 2 to the left. And you look at this and say, oh yeah, that's 1 up. We've already done that, you see. So what the text does is correct. They do some roundabout way of doing that. But if you do it this way, to me, there's less thinking. You've already seen something like that. So, oh yeah, pi over 2 left, 1 up. Right? So we can analyze it. Amplitude is 1. How do I know? The coefficient is 1. If there was a 7, the amplitude is 7. Period is 2 pi divided by 2, which is pi. All right, so here's how we analyze this. First, I drew cosine 2x. Period is pi. Maximum, 0, minimum, 0, maximum. Okay, now, because of this whole graph has to go pi over 2 to the left. So if I take 0 and move it to the left pi over 2, I'm at negative pi over 2. If I'm at pi, I go pi over 2 to the left, I'm at pi over 2. And if I do likewise, so one period is going to go negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. The range is from -1 to 1, but because of the +1, it's going to be from 0 to 2. The range is going to be 0 to 2. So range can be thought of as -1, 1, +1, which is 0 to 2. So the regular range for a cosine or sine is from -1 to 1. But because of this +1 at the end, now my minimum is going to be 0, my maximum is 2. So y equals 1 is now called a midline. It's sort of like the new 0, what used to be called 0. Okay? And technically, that's what I mean by when I go 0, max 0, min 0, it really should more accurately be midline. Maximum, midline, 0, midline. Likewise here, maximum, midline, minimum, midline, maximum. Midline 0 if you don't have any translation up or down, but because we have a translation up or down, the new 0, so to speak, the new midline becomes y equals 1 in this case. Okay, and then for one period, let me write this in, one period. Get this thing focused here. All right, I knew the period was pi, so normally I would say 0 to pi, but I'm translating pi over 2 to the left. So I subtract pi over 2. So one period is going to go from negative pi over 2 to pi over 2. So that says bracket 0 pi. That would normally be the one period for this function, because the period is pi. But because of the horizontal translation of pi over 2 to the left, I go minus pi over 2. So 0 minus pi over 2 is negative pi over 2. That's an equal sign there. And then pi minus pi over 2 is pi over 2. So there we go. Maximum, midline, 0. Sorry, minimum is what I meant to say. Minimum, midline, maximum. It's just a variation of this. Maximum, midline, minimum, midline, maximum for cosine type functions. Okay. So a lot of things going on here, as you can see. Okay, 15. It's a little bit clumsy, to be honest with you. Y equals negative 2 sine of x minus 1 plus 3. So I think of negative 2 sine x first. Ignore that. Negative 2 sine x. Amplitude is 2, but because of the negative, it's going to go 0, minimum 0, maximum 0. So negative 2 sine x goes down 0, up 0. And of course, I've lightly shown, you just copy and paste the rest of it. That's not really the end of the graph. Copy that, paste it, it'll keep going like that forever, and keep going like that forever to the left also. But now we know that this means 1 to the right, 3 up. The period is still 2 pi. There's no coefficient here. So how do I get my new range? So here's the range. Regular sine or cosine is between negative 1 and 1. Then I multiply by the amplitude. The 2 or negative 2, it doesn't matter if it's 2 or negative 2, you multiply that by 2. So now I'm going from negative 2 to 2, right? But then you add 3. So from negative 2 to 2 plus 3. So negative 2 plus 3 is 1. 2 plus 3 is 5. So my new graph is going to go between 1 and 5, where y equals 3 is the midline. Y equals 3 is the midline. It's sort of like the new 0. Now, this gets more clumsy. I have to take all these values and move to the right 1 unit. Well, these all have pi stuff. So how do I add 1 to all these? You literally just do it. So adding 0 to 1 is no big deal. But I got to go pi over 2 plus 1. That's the only way you can write it and keep the exact value. Pi plus 1, 3 pi over 2 plus 1, 2 pi plus 1. Very clumsy. That's the best I can do. Yeah, you can get a decimal approximation if you want to. I don't want to. I don't think you want to either. So there we go. Okay, so very technically, even though here I wrote 0, it should be midline. Midline, maximum, midline, minimum, midline. So in this case, the midline is 3 only because I was told to move the whole graph up 3 units. And because of the negative, okay, the negative means I'm going to switch the maximum and a minimum. So that means it's going to start down. Okay, so this one from here, it goes down to the minimum, which is 1, back to the midline, halfway, 3/4 of the way, it reaches the maximum, 5, and then I'm back to the midline. So here's the entire graph. Yes, question.
On a test, would you accept pi over 2 plus 1 on the x-axis? Would you accept something like that, or would you rather us find the decimal?
So on an exam or quiz or anything, yes, I want it exactly like this. Okay,
Oh, like
pi over
that?
2 plus 1. Yeah, it's very clumsy. I mean, a normal type of problem, they would have me move over a multiple of pi so I can include it. You know, well, like the previous one, right? But you're adding pi over 2 or subtracting pi over 2. That's natural because you already got pi stuff. But here, if you got stuff with pi, did you tell me to add or subtract 1? There's no real nice way to do it except to literally write plus 1.
Mm.
So the only way I
Okay.
can write this as an exact answer is, yeah, to write it as plus 1. Okay. All right. Okay, so that's that one. Okay, 17 has an absolute value in it. Absolute 17, 2 cosine x. We've played that game before with an absolute value. Anything that's below the x-axis, we bounce it into the area that's above the x-axis by doing reflection, right? So first I start off with 2 cosine x. Amplitude is 2, period is 2 pi. So in red, now you can't see all of the red, because the graphs kind of superimpose each other, but red, red. So cosine goes maximum, midline, minimum, midline, maximum. So maximum, midline, yes, it's 0. Minimum, 0, maximum. So look only at this. And now absolute value of the whole thing. So anything that was above stays. Okay, so that stays. So this is red and green. That was already above, it stays. This part was below. So you reflect that across the x-axis and it bounces over here. So you get this funny looking W thing like that. Okay. Okay. Jump to 25. I'll come back to something like 19 later. Find the equation of a sine wave that is obtained by shifting the graph of y equals sine of x to the right 2 units. Okay, so we've played that game before. And down 1 unit and vertically compressed by a factor of 2 when compared to y equals sine x. Okay, right 2, sine parentheses x minus 2. Down 1, minus 1. And then a vertical compression by a factor of 2. That means you put a half in front. It gets shrunk by a half. So there it is, y equals 1/2 sine x minus 2 minus 1. Okay, and let's see, it's 9:45, so I think, yeah, it's already been past 40 minutes, so I don't think we're having issues with that 40-minute thing anymore. But we'll see how it goes. Okay, now for some trickier problems. They give us the graph come up with the equation. That's a lot more work. We're figuring out. Find a cosine function and a sine function whose graph matches the given curve. So how do I do that? So they give me this 0, 3, negative pi over 4, 0, pi over 4, and so on. Can come up with a cosine graph and a sine graph. Let me start off with a cosine graph first. Well, the maximum is 3. The minimum is negative 3. So that tells me the amplitude is 3. What's the period? Negative pi over 4, 0, pi over 4, 2 pi over 4, 3 pi over 4. All right, so one period is from here to here. How far is it from here to here? Well, it's the difference between 3 pi over 4 and negative pi over 4. 3 pi over 4 minus a minus pi over 4 is 4 pi over 4, which is pi. So the period is pi, and I know the formula for the period is 2 pi over b. In other words, 2 pi over b is my pi. Okay, I'll teach you this if you've never seen this before. When you have an equation like this, you're allowed to just swap these two in algebra. Okay, in other words, just put the pi there and the b there. 2 pi over pi is b, and that equals 2. So the b is 2. Okay, maybe I'll take a little time out. If you ever have an equation like this, a equals b over c, you're allowed to just swap these two and say c equals b over a. That's a nice shortcut trick. In fact, we'll be doing a little bit more of that when we get to trig equations like law of sines and law of cosines. This will come very handy. Okay. How can I justify that mathematically? If you multiply both sides by c and then divide by a, you get that. Okay. And it's probably more obvious if I show you some real numbers. Not sure if I showed this to you before. One, 5 equals 15 divided by 3, right? What happens when you swap these two? You say, oh yeah, 3 equals 15 divided by 5. Sure, right? See that? So here's an example of that. So you can just swap these two. So the formula for the period is 2 pi divided by p. By b, I found it to be pi. Fast way to solve it is just swap these two. 2 pi over pi is b. So I know the b is 2. All right, now, if I'm doing a cosine function, it already starts off at the top. So it's good to go. Y equals 3 cosine 2x. However, what if they told me to start as a sine function? Well, they got it starting here. Sine function normally starts here at 0, 0, and I shifted pi over 4 to the left. So I've got the same amplitude, at the same period, but I have to indicate with a sine function a shift of pi over 4 to the left. So for a sine function, this is what it would be. 3 sine 2 parentheses x plus pi over 4. So it's a little bit tricky. Okay. '21. Much harder. Okay, boy, what do they got? 2, 1, 9 halves, 3, and all this other weird stuff here. So what is the amplitude? So here I can use the formula for amplitude: maximum minus minimum divided by 2. The maximum is 3. The minimum is -1. Amplitude is 2. Amplitude is 2. So if I go max minus min divided by 2, the maximum was 3. The minimum was -1. Maximum 3. Minimum was -1. Divide that by 2. That's 4 divided by 2, which is 2. So my amplitude is 2. What is the period? Well, here's one complete up and down. It's going from x equals 2 to x equals 12. So how far is it from 2 to 12? That's 10. Period is 10. Set that equal to the formula 2 pi over b. Swap these two. B equals 2 pi over 10 or pi over 5. Okay. And I had these examples last time I taught it, I guess. It was already here, but anyway. And 0, 0 got moved to 2, 1. This is where a sine function would normally start, right? At the bottom. So for sine function, it would be what? 2 to the right, 1 up. 2 right, 1 up. So y equals 2 sine of pi over 5. That's the b, parentheses x minus 2 plus 1. So that covers everything. A, B, C, and D. A, B, C, and D. Amplitude, period, horizontal shift, vertical shift. 2 sine pi over 5, parentheses x minus 2 plus 1. How about a cosine function? Well, cosine would normally start at the maximum right here. So that's going to be x minus 9/2, right? Plus the midline value of 1. So 2 cosine pi over 5, parentheses, x minus 9/2 plus 1. It's not plus 3, it's plus 1 because I would normally, under these circumstances, start off at 2 as a height, but the new height is 3, so it's just going to be a plus 1 for a cosine type function. And you can see I messed up the first time I did this. So 2 cosine pi over 5, parentheses, x minus 9/2 plus 1. Okay, and the amplitude is maximum minus minimum divided by 2. So 3 minus a minus 1. Maximum is 3, minimum is -1. 3 minus a minus 1 is 4, divided by 2 is 2. So that's what we have over here. Okay, we've covered a lot today, so I think I'll quit for now unless anybody has any questions. And yeah, it seems like we don't have any trouble with that 40-minute rule because I think I've gone past 40 minutes quite a bit now. So hopefully we're good for the rest of the semester. All right, so let me stop the share and check if there's any questions in the chat. And if not, we'll call it a day. I don't see anything there. So any questions, please? Otherwise, we're done.
How did you get the 9 pi over 2 in the cosine equation?
9/2?
Yeah.
Okay, so the 9/2 was because if they wanted a cosine type function, okay, cosine starts off at the maximum. So the horizontal shift would be 9/2.
Oh, that makes sense. Thank you.
Okay, the vertical shift is only 1, not 3, because remember, for cosine, if I didn't have any vertical shift, it would start off at 2 because of the amplitude. So it's only going to be plus 1. Okay. All right, any other questions, please? Otherwise, that's it. Check the chat again.
I like did it a sort of different way. Like first I found the sine function. This is for 21. First I found the sine equation, and since there wasn't much information given, like I just graphed the sine equation, and then like I ended up with a -2 cosine pi over 5 x plus 5 plus 1. moving, I basically just like looked at the, but does it wants only, my question basically is, could I do that? Or like, because it technically is like the same graph, but like, is it only talking about what it's giving us?
Correct. So what you said actually works if you come all the way out to here and then have the graph start down. But based on what they're giving me here, so technically there's infinitely many ways you could do that. You could start at 5, like you said, or add another period on top of that. But based on what we have here, that would be the most natural way to do it. Okay, for everyone
Okay.
else who didn't understand what we were talking about, you don't have to worry about it. I mean, I could technically start way out here. But yeah, what you had said, Bonnie, works if you wanted to start at 5 and start down. Yeah, that would also work.
I said 0.5. I think it was negative 0.5. I went before the x-axis,
Negative
before the
0.5.
y-axis. That
That might actually work also. Yeah. It might work.
So okay, all right. So
Mhm.
so if we're ever faced with this, we should only use the information given in the
Right. Okay. You can understand from my standpoint, from a teacher standpoint, even though what you have is correct, I don't want to try to figure out whether yours works and then someone else has something else and someone else has something else. It's easier for me as a teacher to grade all the papers if everybody does the same thing, obviously. So please, yeah, base it off of information.
So you got a 9 pi over 10, right? Or I mean, like after you multiplied it out. Yeah.
Oh, I didn't bother multiplying it out. In fact, I don't want you to multiply it out. Just leave it like this. I
Oh,
don't see any. I
okay.
don't see any good reason to multiply it out, even though the text may have done it. It would, yeah, it would be negative 9 pi over 10, but don't even bother doing that.
Okay.
That's where the author does something different than what I would do.
Okay.
And I think this is more intuitive. That's it. Okay. All right. Anything else, please? All right, then we'll call it a day. All right. So have a good day, and we'll see everybody next time. All right.
Thank
Bye,
you.
everybody. Thank you.